Hello students, welcome to the Veda Scheme Academy. So in last lecture we have seen the disconnection of the alcohol. So in that we already discussed the disconnection of the primary alcohol, secondary and the tertiary alcohol. And we know that so when alcohols are unsymmetrical, so we have more than one ways to disconnect it. And generally we have seen the two ways for the disconnection of the alcohol. Okay. So in this lecture we are going to discuss the disconnection of amines. Okay, so see here this is nothing but said to be the amines. So we know that the amines also as that of what the this is what the amines. Okay, so we know that amines are nothing but like this. So this is the nothing but said to be the amine. This is said to what the NH2. So this is just an amine, simple primary amine we will consider, and we know how to disconnect this amine. So here as that of what the alcohol, so amines are nothing but formed by means of what the three ways. So the first way we will discuss only two ways, by because suppose if we discuss more than one or more than two ways, so may possible that the student get confused. So we will discuss only two ways, so that is sufficient. Okay. So here the amine formation of the amines is the same as that of what the alcohol. The first thing is nothing but the electro, you can say that the SN2 reaction over what the such as the nitrogen analogous epoxide. Okay, so this is nothing but said to be the first way, and second way is nothing but just by doing the FGI. So when we do what the FGI of this amine, so we got what it is said to be there is a reaction in between the carbonyl compound and the NH2. Okay, so it is nothing but the imine. Okay, so imine formation is nothing but said to one of the way for the disconnection of the amine. Okay, so we discuss first the imine way for the disconnection of the amine. So see here, so this is nothing but said to be the examples where we have the three carbon atoms and attached towards the NH2 group, so the nitrogen which bearing what's the lone pair. Okay, so when we suppose try to disconnect it, when you do what the analysis. Okay, so here it is nothing but said to be the analysis of what this molecule. Okay, so the first thing is nothing but we have to do what the FGI, because we are able to break what this molecule obviously. So this is nothing but said to be the first carbon, this is second carbon, this is what the third carbon. Okay, so in first steps we are going to do what the FGI. So when we do what the FGI, so that amine will be converted into the imine. Okay, so the imine is nothing but imine is formed by the reaction of the carbonyl group along with what the NH2. Okay, so by the elimination of the H2 molecule. So here we got what such type of molecule. So this is nothing but the double bond, and here is nothing but said to be the NH. Okay, so such type of functional group is nothing but here what the carbon double bond, what the nitrogen. This functionality is called as what the imine functionality. Okay, and this functionality we got by the reaction of the carbonyl compounds with what the NH2 in just an the dehydrating agent such as what the concentrated H2SO4, or you can say that the another. Okay, simply there is no I think we are not going to use that, because the amine they having the lone pair, so that's why they will going to do that reaction itself. Okay, so here when we do what the FGI of the amines, we got what this imine, and we know that there is a the disconnection of this bond. This is nothing but said to be the carbon nitrogen bond. Okay, so what we do, so this is nothing but said to be the retrosynthetic arrow, and over this arrow we have to write down what the disc C double bond N. Okay, C double bond N. Why? Because here we have to note that which bond we are going to disconnect. So here we are going to write down what the disc C double bond N. Okay, so when we break this bond, so what we got here, so this is nothing but said to be the CH3 CH2. This is CH3 CH2, and this is nothing but said to be the CH which having the dye-positive charge. Okay, and here is nothing but said to be the NH which having said to be which charge? Dye-negative charge, obviously, because the nitrogen is more electronegative as compared to what the carbon atom. So here maybe I may write down what this CH3 CH2, and this is what this CH. Okay, there is a, you can say that the dye-positive charge, plus here I may write down what the NH in which having what the dye-negative charge. Okay, so now we are talking about what the synthons, or you can say that these are nothing but the synthons generated after the disconnection of this carbon double bond nitrogen. Okay, and when we talk about what say the chemical equivalent of this synthon, so here obviously this CH3, CH2 and CH, they having say the dipositive charge, so we have to attach this the carbonyl group to it. Okay, so we have to make a carbonyl group over here, and here is nothing but said to be the NH2 dinegative. Simply we have to add what say the two hydrogen atoms, so we got what say the NH2, okay, or say NH3. So this is nothing but only NH. Okay, we have to make it what say the NH3. So the chemical equivalent, okay, so the chemical equivalents are nothing but said to be the first one is nothing but said to be the yeah, this one I may write down over here. So the chemical equivalents are nothing but said to be this one. Okay, these are nothing but said to be the aldehydic group, and plus here is nothing but said to be the NH3. So by the reaction of these two, what we got what say such type of species, that is nothing but the imine. And when we do the reduction of this, so either you can do what say the reduction by means of the catalytic reduction, that is what the use of the H2PD, or say another is nothing but said to be the use of the NaBH4. Okay, so when we do say the reduction by means of these two reagents, we got what's the amine as a product. Okay, so this is all about it. Furthermore, what happened here, we got what say this aldehydic, okay, this aldehyde we got, okay, here, and this is nothing but said to be the NH2. This is nothing but what say the NH2. So here what happened, so we got what this moiety. So now what we have to do, we have to just say do the further disconnection of what say the carbonyl group. So how to do the carbonyl group, how to do the disconnection of the carbonyl group, we will going to discuss over here. So I may write down over here, I may write down what say the ET over here, so it is say simply visible for you. Okay, so see here, now we have to do what say the disconnection of this aldehydic group. Okay, so see, aldehydic group is nothing but the product of what say the oxidation product of say the alcohol, primary alcohol. Okay, when you do the oxidation of the primary alcohol by means of say the PCC or say the PDC, okay, these are nothing but say the mild oxidizing reagents. Okay, so those who can oxidizes this primary alcohol into the up to the level of say the aldehyde. Okay, so we are going to use this. So now furthermore, so we will going to take what this, so this is nothing but said to be yeah, this one, this is what say the aldehyde. Okay, now further we do what say the FGI. Okay, so when we do what say the FGI, so it will be converted into what this one, so this is nothing but said to be the OH. Okay, this is what say the primary alcohol. When we do the you can say that when we do the oxidation of this one, so we got what say the aldehyde as a product. Okay, so here we know, say in last lecture we already seen the disconnection of the primary alcohol, so obviously it is nothing but said to be, yeah, we will going to disconnect it here, what say the disc. Okay, disc, and what we do, so this is nothing but we are going to disconnect from here, it is nothing but a 1 2 3. So here we will going to do what say the 1 2 disconnection. Here we can write down CC. Okay, 1 2 disconnection. So what we got what say this say CH3 CH2 plus here is nothing but said to be the OH. So obviously when we do the 1 2 disconnection, oxygen becomes the negative charge. Okay, we are going to assume it. Okay, and the oxygen is negative charge, so the carbon atom becomes what say the positive, and obviously this carbon atom is what say the negative charge. So these are nothing but the synthons generated after the disconnection of the say the primary alcohol. And then when we talk about what say their chemical equivalent, so obviously this is nothing but said to be the ET, so we can write down it ETMgBr, ethyl magnesium bromide, where the ET will go into negative and Mg is nothing but said to be the positive. And here obviously, so this is nothing but said to be, say here we have to say only eliminate this hydrogen atom and make them say said to be what say the aldehyde. So it should be what say the CH2 double bond O, it is nothing but the formaldehyde. So we know that the formaldehyde when reacted with what say the Grignard reagent, so after hydrolysis we got obviously primary alcohol. So further we are able to do the disconnection of this one, so it should be what say the ETBr. Okay, ETBr, and plus here we can write down what say the Mg in say the zero oxidation state. Okay, so this is all about nothing but said to be the disconnection of the amine. So we're going to say remind this. So this is nothing but said to be, this is what say the CH2, this is CH3 CH2 CH2 NH2, this is primary amine. Okay, so what we do in first step, we do what say the FGI. Okay, and what we got say the imine as a product. So this is nothing but said to be the carbon double bond nitrogen. Okay, so then we are going to disconnect this carbon nitrogen double bond, because we know that this bond can be formed by the reaction of the carbonyl group with what say the NH3. Okay, So we are going to disconnect it. So here we will going to write down what the disk, you can say that disk C double bond N, and what are the syntons? So syntons we got is nothing but CH3, CH2 and CH, they are having say the di-positive charge, and this one is nothing but said to be the NH2 di-negative. Okay, so the chemical equivalents of this are nothing but said to be this one. So this is nothing but said to be the ET. This is what the propanol means what? CH3, CH2, C double bond O, and along with what say the NH3. Okay, so this is all about what say the first steps. Okay, or so you can say that the first steps. And furthermore we got what say the aldehyde, and the aldehyde is furthermore say the disconnected by say by doing say the FGI. So when we do what say the FGI, we got what the primary alcohol, and we already know that primary alcohol is disconnected by using say the reaction in between say the aldehyde and Grignard reagent. So we're going to do the 1,2 disconnection. Okay, we got what say this one. This is what the CH3 CH2 negative charge, and here is nothing but said to be the CH2 OH. So only removing say the proton or the hydrogen, we got what say the formaldehyde, and here so make this CH3 CH2 negative is nothing but the ETMgBr, that is what the ethyl magnesium bromide, and they can be got from what say the ethyl bromide on the action by the action of what say the Mg in zero oxidation state. Okay, so this is all about what say their analysis. Now we have to move towards what say the synthesis of this molecule. So how we do the synthesis of this molecule? Okay, so I may write down here what say the synthesis part. Okay, synthesis, yeah. So the reaction can be started from what this one. So it should be is nothing but the ETBr. Okay, so I may write down what say the ETBr. So this is nothing but our precursor. So in first step what we have to write down? Yes, obviously we are going to write down what say the Mg. Here is nothing but the Mg in what say the THF. Okay, so the THF is nothing but the solvent. Tetrahydrofuran is nothing but the solvent in zero oxidation state. Why we are going to use this THF? Because it can stabilizes this Mg. And then next is nothing but said to be, so when we add this, what we got what say this ETMgBr. Okay, so after that we have to react it with what say the, in next step we have to add what say this formaldehyde. So we will going to write down what this CH2 double bond here oxygen. So this is nothing but said to be say the reaction in between the ethyl magnesium bromide with what say this formaldehyde. Okay, so after the reaction in between these two, we got what say this one, but here we will going to write down what say the H3O positive. Why H3O positive? Because obviously in case of what say the H3O positive, we got what say the hydrolysis result say the primary alcohol. Okay, see what, when we do say the disconnection or say disconnection of the primary and secondary alcohol, in that case we are going to do the hydrolysis by using the H3O positive, but when we do the reaction of the ketone with the Grignard reagent, so obviously we got say the tertiary alcohol. So here say the, we can say that the hydrolysis cannot be done with the help of the H3O positive because it is a strong acidic medium. When you do the hydrolysis of say the tertiary alcohol in presence of the H3O positive, so it may possible that tertiary alcohol will get say undergo the elimination reaction. Okay, and instead of what say the tertiary alcohol, we got what the alkene as a product. So that whenever we have to do the hydrolysis of the tertiary alcohol, so we have to use the weak acidic medium, that is nothing but the NH4Cl and H2O. Okay, so I will want to remind that whenever we have to do the hydrolysis of tertiary alcohol, so we have to use the NH4Cl and H2O. Okay, so it is a weak acidic medium, so that the say the tertiary alcohol only get you can say that the hydrolyzed, they will not undergo say the elimination reaction. Okay, so that you keep these things in your mind. Okay, and then next what we got what say this say the alcohol. Okay, then after we have to convert this primary alcohol into the aldehyde. So obviously there is a use of what say the oxidizing reagent, mild oxidizing reagent. I may write down over here what the PCC. Okay, pyridine chlorochromate. Okay, so this is nothing but said to be the complex. Okay, PCC able to say convert this primary alcohol into the aldehyde. Okay, so what we got say the aldehyde. Now this aldehyde we have to convert into what say this you can say that the imine. Okay, so we have to move like that. Okay, so we have to say convert this aldehyde into the imine. Simply you have to add what say this here I may write down, this is what the fifth, we have to say, yeah, this is nothing but said to be the NH3. Okay, so we have to react it with this NH3 in presence of some dehydrating agent. Okay, so what we got what, say, this imine. Okay, imine as a product, and finally we have to do, say, the catalytic reduction. Either we have to do the catalytic reduction, or say the NaBH4 is sufficient to convert this imine into what, say, the amine as a product, and here we got what, say, the target molecule. Okay, so this is nothing but said to be the simple say the disconnection of the primary amine. Okay, so obviously this is very simple. Okay, this is very simple. So this is nothing but the first way to convert this amine into the imine. Okay, and just by doing, say, the disconnection of carbon double bond nitrogen, okay, carbon double bond nitrogens, we are able to do say the disconnection of this. Okay, so this is all about say the disconnection of, say, the primary amine, and this is what, say, the first way, okay, for the disconnection of the primary amine. Now say we move towards what, say, the second way, where say you can say that those primary amine which having more than 3 carbon atoms in their structure, as that of what, say the primary alcohol, which we already seen in the last lecture. Suppose if say the primary amine contain more than 3 carbon atom. Okay, so we'll take an example, and just by taking example we're going to explain it.